Alright, so here we are on Lesson 8, equivalent ratios defined through the value of the ratio. So this first definition we have here is the value of a ratio. And it says when given a ratio A to B, where B does not equal 0, we call the quotient A to B the value of the ratio. Alright, so the value just means to simplify the ratio. So write yourself a note here. Simplify the ratio. Alright, that's all that value really means. So in exercise 1 it says circle any equivalent ratios from the list below. Alright, so if we look at 1 to 2, alright, and we've practiced equivalent ratios before, and we have the ratio of 5 to 10, right here we've just multiplied by 5 both times, so these two are equivalent. Alright, and then if we look at 6 to 16, and 12 to 32, we multiply these both by 2, right, then that is 12 to 32, so these are also both equivalent. Alright, part B says to find the value of the following ratios, leaving your answer as a fraction, but rewrite the fraction using the largest possible unit. Alright, so again, to find the value just means to simplify. Alright, so here we have the ratio 1 to 2, so we need to write it as a fraction, which would be 1 over 2. And we can't simplify this anymore, so this is our final answer. Alright, so for 5 to 10 here, we need to write it first as a fraction, which would be 5 over 10. Alright, and we ask ourselves, can we simplify? And we can. We can divide both numbers by 5. So our final answer here would be 1/2. Alright, and this is the value of the ratio. Right here we have 6 to 16, so first we write it as a fraction. And then we ask ourselves, can we simplify? And yes, we can. We can divide both numbers by 2. So go ahead and do that. So then we get 3 over 8. And that is the value of our ratio. We can't simplify anymore. Alright, and then the last one here, we have 12 to 32. So first we have to write it as a fraction. We have 12 over 32. And we can divide both of those numbers, if you think about it, by 4. So we're going to divide them both by 4. And that way we get 3 over 8, and that is the value of the ratio. Alright, so part C says true or false. The value of the ratio is the same for equivalent ratios. Alright, value again just means to simplify. Alright, so would it be the same for equivalent ratios? So if the fractions are equivalent, it would be the same, right? So the answer is true. Alright, the value of the ratio is the same for equivalent ratios. Alright, moving on to the next page. We're on page 24 now, last page of the packet. We have exercise 3. It says Terry is training for a dualathon, which is a race that consists of running and cycling. So I'm going to underline those. The cycling leg is longer than the running leg of the race. So while Terry trains, he rides his bike more than he runs. During training, Terry runs 4 miles for every 14 miles he rides his bike. So it says identify the ratio associated with the problem and find its value. So if we look back, we are comparing running, like run to bike, right? Those are the two things that Terry does. So it says here, Terry runs 4 miles, so the first number is going to be 4, for every 14 that he bikes. So our ratio is going to be 4 to 14 based off of what they told us. All right, so now the value of the ratio, again, value means to simplify. Don't know why all these lines are popping up. So then we're going to write it as a fraction first, so 4 over 14. We can divide both of those by 2. So our value would be 2 to 7, and this is our final answer here. Alright, So then the next example says, use the value of each ratio to solve the following. When Terry completed all of his training for the duathlon, the ratio of the total number of miles he ran to the total number of miles he cycled was 80 to 280. Is this possible according to Terry's training schedule? Why or why not? So first we need to write out the ratio as a fraction, right? So we are looking to total run over total bike. Those are the two things we are comparing. So we know, based off of what they told us, this is going to be 80 over 280. So now we need to simplify, right? We have to find the value. So they both end in a 0, so we can divide them both by 10. So that means we would get 8 over 28. And then we can divide both of those by 4. So then we would get 2 over 7. And we can't simplify this anymore. So it's asking, is this possible? And the answer is yes. Because the ratios are equivalent because their values are the same. So we can say yes, the ratios are equivalent. Alright, so one more example here. Part C says, in one training session, Terry ran 4 miles and cycled 7 miles. Did this training session represent an equivalent ratio of the distance he ran to the distance he cycled? Explain why or why not. So we are comparing run to bike. Alright, and they told us that it was 4 to 7. So can we simplify this at all? And we look at this and no, we can't. Alright, so now we see that this does not equal the value that we've used above, 2 to 7. So no, this is impossible because the ratios are not equivalent. Alright, so we're going to say no because the ratios are not equivalent. Alright, and that is it for this whole unit. Alright, so bring any questions you have to class tomorrow and we will go over them.